Alright, so 889, algebraically find the intersection of the two functions below. Then make a complete graph of the system on graph paper and confirm your solution. Alright, so there's a slight change that we need to make to the problem, otherwise we get some really nasty numbers. Is this second equation here has to be a plus. And this is like the ski jump problem, so we want to find where they intersect, so we set them equal to each other. So then you get x squared plus 5x plus 8 equals x plus 5, and then you get x squared plus 4x, because we're subtracting x, and then subtract 5 and you get plus 3 equals 0. And what makes this problem real nice is we can factor it, so then you get x plus 1 and then times x plus 3 equals 0. And so then we get x plus 1 equals 0, and so x equals negative 1, and then x plus 3 equals 0, so we get x equals negative 3. Alright, so we know the x values where they intersect, so now we substitute them in to either equation to solve for y, and obviously let's substitute into the easy equation. And so for this value, if we have y equals x plus 5 and we substitute in negative 1, we get negative 1 plus 5, so then y equals 5. So when x is negative 1, y is 5. So that's one of our intersections. And then y equals x plus 5. If I substitute negative 3 in, I get y equals negative 3 plus 5. So y equals 2. And so when x is negative 3, y is 2. And so these, oh, I just noticed I had a little math mistake here, guys. Negative 1 plus 5 isn't 5, it's 4. So this would be 4. So this is a 4. Alright, so now we know that these are our intersections, and so they asked us to make a graph so that we can look at this. So let's graph x plus 5. So 1, 2, 3, 4, 5. So we go up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And so let's put in a line for that. So we get a nice line there. Alright, so now we want to graph the x squared, y equals x squared plus 5x plus 8. So I'm just going to use a different color. I'm going to use red here. Alright, so we know what the y-intercept is, 5, 6, 7, 8. So we intersect there. I'm just going to use the vertex form and convert this. So I know that y equals x plus 2.5 squared, and then 2.5 times 2.5 is 6.25. So this is minus 6.25 plus 8. So then this ends up being y equals x plus 2.5 squared plus 1.75. So this roughly, the vertex is going to be over 1, 2 and a half, and then up 1.75, like right in here. Oopsie, I don't want that. It's going to be roughly here. My intersections are at negative 1, 4, so here, and negative 3, 1, 2, 3, 2, which is here. This is my axis of symmetry right here. I know I have another point equally on the other side. So I have a graph that looks kind of like this. Not exact, but pretty close. And so there's a graphical representation of our solutions, and then the algebraic version of our solutions.